My name is Engineer Ahmed Abdelgaid, HSE Consultant at Tractable NG. Thank you for joining this important training session. This is the third lecture in our lifting safety series. So far, we've covered the core components of safe lifting operations, including planning, risk assessment, and team roles. Today, we take it further by focusing on advanced rigging concepts and analyzing real-life failures to prevent future incidents. This session will focus on rigging calculations, load angle and tension analysis, case studies of lifting failures and how to prevent them, why rigging calculations matter. Rigging isn't guesswork, it's engineering in motion. Incorrect rigging decisions, such as misjudging sling angles or load balance, are among the top causes of serious lifting accidents. If the calculations are wrong, it can lead to excessive stress on the slings or equipment, resulting in failure. Every competent lifting team must understand the following. How to calculate sling tension. The team must understand how to determine the tension in the slings based on the load. The slings will be under significant stress, and incorrect tension calculations can lead to sling failure or even a total collapse of the lifting system. How angles affect forces. If the sling angles are incorrect, it directly impacts the distribution of forces. Sharp angles can cause an uneven load distribution, increasing pressure on the slings or lifting equipment, which may lead to failure. How to ensure loads are rigged safely and evenly. It's essential to ensure that the load is distributed evenly across the slings or lifting gear. Uneven load distribution can result in sudden or unexpected movements, putting the site and personnel at risk. Key rigging concepts. Load weight and center of gravity. Always determine the exact weight of the load and locate its center of gravity, CG. If the CG is hidden or off-center, it can cause unexpected tilting or rotation when lifted. Knowing the CG ensures the load remains stable throughout the lift. Sling angle factor. The sharper the sling angle, the greater the force placed on each sling. For instance, with a 30-degree sling angle, the tension on the sling can be double compared to when lifting vertically. Sharp angles increase the load on the slings, so you need to consider the angle to prevent overloading them. Load distribution. In multi-sling systems, the weight isn't always evenly distributed. The actual load on each sling depends on the angle and geometry of the rigging setup. Proper calculations are necessary to ensure each sling is carrying its share of the load to prevent failure. Sling capacity and safety factor. Never operate near the working load limit, WLL, of any sling. Always add a safety margin to ensure you are well within the sling's capabilities. This is especially important in harsh or dynamic conditions where forces can fluctuate and put additional strain on the slings. The basic formula for calculating sling tension is to divide the load by the number of slings and then multiply by 1 divided by the cosine of the sling angle. Load is the weight of the item being lifted. Number of slings refers to how many slings are being used in the lift. Theta is the angle between the sling and the horizontal measured in degrees. Example calculation. Let's assume we have a 2-ton load, 2,000 kilograms, and we're using 2 slings to lift it with an angle of 45 degrees. Now we apply the formula, divide the 2,000 kilograms by 2, then multiply by 1 divided by the cosine of 45 degrees. The result will be 1,414 kilograms per sling. If each sling is rated for 1,000 kilograms, the calculated tension of 1,414 kilograms exceeds the sling's capacity, which means the sling will fail. Key takeaways. The sharper the sling angle, the higher the force on the sling. Always ensure your slings can handle the calculated tension to avoid equipment failure. Have you ever wondered what common mistakes occur during lifting operations? Let's take a look at some of the most frequent errors, as they can lead to serious accidents if not avoided. Too narrow sling angles. When the sling angle is too sharp, it increases the tension on the sling significantly. This puts extra stress on the sling, making it more likely to fail. It's always best to maintain a more moderate angle to reduce the pressure. Uneven load distribution due to poor rigging geometry. Sometimes the load isn't distributed evenly between slings. If the weight is unevenly spread, some slings will bear more load than others, which increases the risk of failure. Proper load distribution is key to ensuring that each sling is working within its capacity. Using worn or damaged slings. Worn out or damaged slings are a major safety hazard. Failure to regularly inspect the slings can lead to them breaking unexpectedly, even when the load is under their rated capacity. Regular inspection and replacement of damaged slings are crucial for safety. relying on guesswork instead of proper calculations. One of the biggest mistakes is relying on guesswork rather than engineering calculations. Properly calculating the forces on each sling ensures that each one is working within its rated limits and prevents overloading. No visual inspection or load test before lifting. Before beginning any lift, it's essential to verify that all components of the rigging system are in good condition. A thorough visual inspection and load test will ensure that everything is safe to proceed. Let's dive into a case study of a sling breakage during a panel lift to understand what went wrong. What happened? In this case, a precast panel was lifted using 4 slings, but something went terribly wrong. One sling ended up bearing over 60% of the total weight, and in the middle of the lift, it snapped mid-air. Why did this happen? Let's break it down. Center of gravity wasn't identified. The center of gravity, CG, of the load wasn't located properly. This is a critical step because if the CG is off, it can cause the load to tilt or shift during the lift, placing more pressure on certain slings. Sling tension wasn't calculated. Without proper tension calculations, the slings may be exposed to forces far beyond what they were rated to handle. This increases the risk of failure. No load equalization or spreader bar used. A spreader bar or load equalization system wasn't used. This meant that the weight wasn't evenly distributed across the slings and one sling ended up carrying too much weight. How can we prevent this from happening? Here's what we need to do. Always determine load balance. Before any lift, we need to ensure the weight is equally distributed. This starts with identifying the center of gravity. Use spreader beams. A spreader beam helps distribute the load evenly across all slings, reducing the risk of one sling taking too much strain. Perform rigging calculations before the lift. Always calculate the sling tensions and the forces acting on the load. This ensures no sling is overloaded during the lift. And of course, MMA, monitor, measure, adjust. Continuous checks and adjustments are essential for safety in any lifting operation. Now let's look at another case study, this time involving a crane tipping on soft ground. What happened? In this case, a mobile crane overturned during the lifting operation, even though the load was within the crane's capacity. The crane tipped over unexpectedly during the lift. Why did this happen? Here are the key factors. No ground assessment was done. A proper ground assessment wasn't performed before the lift. Soft or uneven ground can cause the crane to lose stability. Outriggers were placed on soft soil without mats. The crane's outriggers were placed directly on soft soil without using mats or plates. This caused the outriggers to sink, reducing the crane's stability. Load shifted during swing. When the load was swung, it caused a sudden shift in the crane's center of gravity, leading to the tipping. How to prevent it? Here's how we can avoid such incidents. Check ground compaction. Always assess the ground to ensure it's compact enough to support the weight of the crane. Soft or unstable soil can cause the crane to lose balance. Use outrigger mats or plates. It's essential to place outrigger mats or plates under the outriggers to distribute the crane's weight evenly. This helps prevent sinking into soft soil. Include site condition analysis in the lift plan. Before starting the lift, the site conditions should be carefully analyzed and included in the lift plan. If the ground is soft or uneven, additional precautions should be taken. And always remember gamma, ground assessment, mats, monitoring, and adjustments. Always assess the ground, use mats, monitor the situation, and make adjustments as needed. Key takeaways, what this means for us. Let's summarize the key points from today's session and what they mean for our safety and success in lifting operations. Rigging must be calculated, not estimated. Precision is key. Every decision in rigging should be based on exact calculations, not guesses. Estimating the load capacity or sling tension can lead to dangerous mistakes. Always use math to guide your rigging decisions to ensure safety. The small details prevent big disasters. It's the little things that make the biggest difference. Thorough inspection and preparation are critical. What may seem like a minor issue, such as a small miscalculation or a forgotten check, can quickly turn into a major safety hazard. Addressing small issues before they escalate is essential to preventing accidents. Center of gravity is everything. Understanding the center of gravity, CG, of the load is crucial. Load balance and the CG determine how stable the load will be during the lift. Without identifying the CG, we risk unexpected movements, tipping, or uneven loading. It's essential to check and plan for the CG before any lift. Everyone on the team must understand the load path. Lifting is a team effort. Every team member should know their role and the path of the load. Understanding where the load is going, how it will be moved, and what to expect at every step ensures the operation goes smoothly. Clear communication is critical for a successful lift. The safest lifts are the ones that never surprise you. This means, with proper preparation, calculation, and communication, every lift should go as planned, without any unexpected challenges. By following the best practices we've discussed, you can prevent surprises and keep everyone safe. This is the last part of today's session, and here's a preview of what we'll cover next. Crane load charts and stability limits. We'll learn how to read and understand crane load charts, which are key to ensuring the crane is lifting within its safe limits. We'll also cover stability limits to prevent tipping or losing balance. Understanding capacity calculations and tipping points. We'll focus on capacity calculations for cranes and identify tipping points, the critical moment when a crane's stability is at risk during a lift. Permit-to-lift systems. We'll introduce the permit-to-lift system, which ensures that all safety checks and approvals are in place before a lift begins. This system adds an essential layer of control to prevent unexpected issues. Implementing robust administrative controls. Administrative controls play a big role in lifting safety. We'll discuss how to implement strong administrative measures to ensure safety protocols and regulatory standards are met. Auditing lifting operations. Audits are crucial for maintaining safety in lifting operations. We'll discuss how to conduct audits that help identify risks and ensure compliance with safety standards. Effective supervision and verification procedures. Proper supervision is vital for overseeing safe lifting operations. We'll talk about verification procedures to ensure everything is in place and everyone is following safety guidelines. Emergency response. Finally, we'll go through emergency response procedures for lifting operations. Being prepared for potential lifting failures and knowing the right protocols to follow in emergencies is crucial for protecting lives and equipment. With that, we've covered the key points for today's session. I hope you found the information valuable and that it will help you ensure safer lifting operations moving forward. Thank you for your attention, and I look forward to seeing you in the next session. Until then, stay safe and goodbye for now.